Hi, my name is Nia George, and this is my video for Physics 1251 for problem set number 5. So our first question is about a child that is sitting on a fiberglass goose, and they are fastened 7.2 meters from the center of a merry-go-round that rotates once every 7 seconds. So our first question about this problem is, what is the child's speed while sitting on the goose? So we need to define our variables first. So we know that our distance from the center is 7.2 meters because that's what it gives us here. And we know that our period, or our t here, is 7 seconds. So we can go ahead and use the formula 2 pi r divided by the period, 2 pi r divided by t. And we know most of these variables. So we know that the radius is equal to 7.2 because it tells us that its distance from the center of the circle, which is the radius, is 7.2. So we know that it's 2 pi times 7.2 over 7. And that will give us, if we type it into our calculator, it will give us a value of 6.46 meters per second because you're virtually going to have 7 seconds on the bottom and then a distance of meters on the top. So it will give us meters per second, aka our velocity. So for our next part of the problem, we're trying to find what our acceleration is. So in order to find the acceleration, we can use the a equals b squared divided by r formula. And we know that we just solved for the velocity in this equation right here. So, and we already know the radius that we have because it was given to us originally here at 7.2 meters. So we can just plug in and find. So a is equal to 6.46 squared divided by 7.2. And then we can plug that into our calculator, and we can actually use this value given and square that and divide that by 7.2. And that will give us a value of 5.8 meters per second squared because it is an acceleration, so that has to be our units. So in this next part of our question, our 3-part question, this next part is asking us this acceleration of the child. So basically what we just did, but it's changing our distance, which means that we have to go back and we have to solve again for a new velocity like we did in this original equation here. But since we changed the distance, we need to go back and do the exact same thing with a different velocity this time. So we know that our x is 6 meters now, and that our t is still 7 seconds. So we can use the same formula we used the first time, which is 2 pi r over t, and then plug in 2 pi times 6 over 7. And then it'll be basically 12 pi divided by 7, which is 5.385 meters per second. So that is our new velocity for this specific part of the problem. And then using that velocity, we can calculate for the acceleration because that's what the question was originally asking for. So then we can use the a equals b squared r formula again. So we go and we use that and plug in our new things. So we can use 5.385 squared divided by 6, because that is our new radius, and we can use this original, square that, and divide that by 6, which will give us a value of 4.83 meters per second squared, which is our final answer and the end of our problems.